Okay, in this tutorial, I'm going to give you 4 or 5 evaluations of techniques that might affect the quality of your data. And what I would recommend you do after you have written up your methods for your data gathering that you're using for the actual data, for the characteristics that you happen to be studying, that you select a couple of these and explain the issue that's affecting the quality of your data and possibly what you could do to resolve the issue. Now, the first problem is when you're measuring the width of the river. Now, the width of the river is the width from one bank of the river to the other, okay? And obviously the width is affected by how much water is in the river at any given time. Now, on this side, it's quite easy to see where the width would be. For example, so if we're measuring this exact spot here, we can see that this is the edge of the water right there. The problem on the other side is that getting the exact width is more difficult because we have a lot of overhanging vegetation, and getting into the exact location where the width is can be difficult. You can often not even see it if you've got a lot of vegetation overhanging, or in the case we can see a nettle here that might cause you to get stung or something. So the accuracy of your data is going to be potentially compromised by riverbanks, which are often overhanging. All the way along a river, you're often going to get a lot of overhanging vegetation. So that's your first limitation. It's going to affect the quality of your data for the width of your river channel. Right, a second limitation of gathering data that's worthwhile commenting on is where you actually record the discharge of a river. So a lot of your data is going to reflect the exact location you choose. Now, if I was, for example, going to choose to this location up here as location to record the discharge of the river, I can see a very flat gradient. The water's moving very slowly. It's really quite silty because you can see the material in the river is being transported. And the characteristics of my river in this location are going to be very different from literally 5 meters downstream where the gradient suddenly changes. Now, if I was a group of students studying in the location of the mini waterfall down there, I would get very different data in terms of my rock size, my rock shape, the efficiency of my channel, and its discharge than if I was at this particular location. So your sampling technique becomes really important in terms of selecting the sites. You shouldn't be selecting the sites based on your own choice or preference. You need a really robust sampling technique, which is going to provide you with a location which you cannot influence. What's important when we think about sampling and how it can influence the quality of the location we choose is obviously going to be the safety of an environment. And on river studies, we can't just access a river in all locations. Upstream under the bridge there is a location that might be too dangerous. It's quite steep, it's going to be slippy, and therefore gathering data in that particular location is not going to be convenient. It does mean, however, we end up choosing locations that are safe, but by definition, these safe locations often are very similar. They're parts of the river which are relatively shallow, flat, and easy to study. But we end up, that's only part of the river we end up measuring. We don't really end up measuring other parts of the river like downstream because they're not safe enough. So we end up with inaccurate data that's not reflective of the whole river. It's only reflective of locations that are relatively safe to study. So that's a second limitation where our data, in this case discharge, can be quite severely influenced by the choice of our location to gather our data. The next limitation comes from sediment size. Now, in the gathering data explanation, you were putting a ruler into the river, and the ruler would land on a rock, for example, this one here, and then that is the rock that you would measure the shape and the size of. But actually, sitting on top of this rock, there may have been a very small fragment of sediment which we didn't realize, like we can see here, that you're not measuring. And that's the limitation of this technique. Bed load, in terms of rock size and shape, includes everything from tiny little fragments like we can see here to much larger rocks like we can see there. But due to the size of the very small sediment, it ends up not being captured in our data, and we only end up generally catching data that is larger in size. So we ignore the small stuff. And actually, if we go just upstream, we can see that in this part of the river, because it's traveling much slower, there is an awful lot of very small sediment. I'll just reach in and show you how much smaller material is in the river here, just to demonstrate that. There's an absolute ton being laid down because it's slow flowing and depositing material. So in this location, we are not capturing the actual, all of the smaller stuff. Downstream, you're not likely to find as much of that small stuff because when the current's much stronger, it washes away the smaller stuff. So our technique for gathering bedload shape and size is not effective at gathering the very small material. And if we wanted to do that, we'd probably need to lay down sediment traps, which can capture the very small material and allow us to truly measure what the average size and shape of bedload at our location actually is. Okay, now there are lots of limitations when you're gathering your discharge data, especially the velocity data, which you will be gathering using the flow meter. And the first limitation is when the river is very shallow, like we can see down here, it can become impossible to get the full propeller under the water. And now what's very important is that you consistently use the same method. So the propeller should always be submerged just below the surface of the river channel. But because the river channel is so shallow here, we've not been able to get it fully under, and therefore we're not accurately recording the flow because some of the water is above the surface and is therefore being affected by other dynamics like wind. So that's one impact that gathering your velocity can. Obviously, you could change where you actually put your flow meter, but that would then be not using a fair sampling system. Another problem which you can see being demonstrated in the flow meter here is it gets stuck every now and again, and that's because it's so shallow that the propeller is actually hitting rocks on the base of the river channel, which is affecting it as it turns. And that's a problem when the river is very shallow again. There is other equipment you can use that can gather the speed of a river, which doesn't rely on this little impeller spinning, but unfortunately it's far more expensive and not suitable for field work of this type. And therefore we rely on the flow meter. Now I'm just going to show you one more issue of using a flow meter to get accurate speed data over here at another part of the river channel. Okay, so another limitation relates to very slow parts of a river channel. So here we are standing at a point where the river's seemingly not moving at all, and we can see that because the propeller is not moving at all. Now, of course, there is a slight current in this river, and I can demonstrate this by putting a leaf and floating it on the top. And you can see that the leaf is moving. So there is a current. It's just so slow, it's got not enough energy to actually push the propeller. And in this case, we could stand here for an entire minute and we would record nothing because our propeller is not sensitive enough. To get around this problem, we'd either have to choose another location, but once again, that compromises our sampling technique, or we could actually use a different piece of equipment that's more sensitive to the flow of the river. Unfortunately, they tend to be far more expensive and are therefore not appropriate for this type of study. Okay, so together I've reviewed a range of issues that affect your gathering of data and how accurate it is. I wouldn't suggest you write about all of them, but you select at least 2 of them to write about. Always explain what the problem is and how it influences the quality of your data. And you could also include in that what you might then do to try to improve on it to make sure it isn't a problem that affects the quality of your data.